All right, diving in today, you guys sent in a ton on pectinase. This enzyme is apparently everywhere but behind the scenes. So let's figure out why it's such a big deal, how it's made, all that.
It's fascinating, actually, because we're really talking about pectin itself first. You know, that polysaccharide. It's like the glue, the structure in plant cell walls.
Right, holds it all together.
Exactly. So pectinase is the thing that breaks that apart, and that has, well, more consequences than you'd think.
Huge implications.
Yeah.
And your sources all point to fungi as the, I guess, pectinase factory workers,
Mhm.
specifically Aspergillus niger. Why is that the top microbe for the job?
Well, it's kind of amazing. Aspergillus niger doesn't just make one kind of pectinase. It pumps out a whole variety, polygalacturanases, pectin
Well,
lyases.
hold on. Those are different ways of breaking down pectin.
Exactly. Think of polygalacturanases as like the main scissors. Pectin lyases, they chop it up a bit differently. And then you've got pectin esterases. They kind of prep the pectin to be cut easier, like a softening agent almost.
Okay, so a whole enzyme toolkit.
And on top of that, Aniger has that GRAS status, generally recognized as safe. So perfect for anything food related.
Right, that makes sense. Now, your stuff also mentioned Aspergillus almomori and some bacteria. What about them?
They have their uses, sure. Some bacteria like Bacillus, they're good at specific types of those lyases we talked about. But overall, Aniger is just, well, it's got the output and the variety. It's the workhorse.
All in one package. So then, how do we get these microbes to actually make pectinase?
Fermentation, of course.
Yeah.
Two main methods. Submerged fermentation, that's SMF, and solid state fermentation, SSF.
Okay, and SMF is the more common one.
Industrially, yeah.
Yeah.
Much easier to control. You've got these microbes in a liquid, nice and nutrient-rich, keeping the temperature steady, the pH.
And the sources mentioned feeding them things like citrus peels.
Oh, yeah, that's key. Citrus peels, apple pomace, stuff like that. Those act as inducers,
Yeah.
basically tell the microbes, hey, start making pectinase.
Interesting. And SSF, that's growing them on solids, like those peels we just talked about.
Precisely.
Mm.
It can be very cost-effective using up agricultural waste and all that, but harder to control precisely, moisture levels and such. So it has its place, but SMF is the big one.
That makes sense. So fermentation's done. We've got our pectinase. How do we get it out and ready to use?
That's product recovery, or downstream processing. For SMF, you first separate out the liquid with the enzyme, then you concentrate it. Ultrafiltration is common, like a really, really fine filter.
Getting all the good stuff.
And if you need it super pure, then there's chromatography and other methods. Finally, you formulate it either as a liquid or powder, make it stable and ready to go.
So, time for the payoff. Where is all this pectinase actually used? Your sources make it sound like fruit juice is huge.
Absolutely. Think about it. You've got this, let's say, apple juice, straight from the fruit. It's cloudy, kind of murky. Nobody wants that.
Yeah, I want my juice clear.
Exactly. Pectinase breaks down the stuff that makes it cloudy. Bam! Crystal clear juice. Plus, it helps get more juice out of the pulp and makes it less viscous, easier to process.
So we can thank pectinase for our smooth-flowing juice.
In a lot of cases, yeah. And the same principle applies to wine. Clarifies it, helps get more color out of those red grapes, even boosts the aroma.
So it's like a multitasker enzyme. Your sources also mentioned vegetables and even the paper industry.
Yeah, it's wild. For vegetables, it's very similar to fruit juice, clarifies things, helps with processing.
Hmm.
And for plant fibers like flax, it helps separate those fibers more efficiently.
Interesting.
And in paper. They use it for biobleaching, a more environmentally friendly way to get that bright white paper using fewer harsh chemicals. It can even help with making animal feed more digestible.
So it's really all over the place. To sum up, pectinase, mostly made by fungi, specifically Aspergillus niger, through these cool fermentation processes, is a truly versatile enzyme and really shows what these tiny biocatalysts can do.
It's a great example of that, yeah. And it makes you wonder, what other plant-based stuff out there could we be using better or differently with the right enzymes? There's a lot of potential in that area, definitely.
Huge potential. And with that, we wrap up another deep dive. Thanks for listening.
Thanks for having me.
Always a pleasure. Until next time, keep those questions coming.
And keep exploring.